SSA. We're going to be proving this. RHS, SAS, ASA, AAS, and SSS. These are the real congruency criteria, while this one is conditional. But what's the difference between SSA and SAS? Well, take these two triangles. These two have two sides and one angle in between them equal. So you read it as SAS. The same for this triangle, SAS. While if you take this triangle which has two adjacent sides and one angle, you read it as ASS, or in reverse SSA. We're going to be proving this. But is it even possible to construct this? Well, here's a small geometric proof. Since we already know the length of one side, we can construct it and then the second side at some angle and take the third side at all possible angles. So we can just draw a circle, and as you can see there are 2 points of intersection. But to resolve this conflict, we'll need to use something else. Now to start proving this, let's take these two triangles and label the sides that we do know as x, y, and theta, and our goal will be to equate z and w so that we can use SSS to prove SSA. Using the cosine rule on this triangle, we can say that y square equals x square plus z square minus 2xz into cosine of theta. Now let's arrange it in terms of z, and you can see that this has a quite familiar pattern. Now this entire equation equals 0, so we can use the most overused formula in all of mathematics, the quadratic formula. Writing it in terms of z gives us negative b plus minus under root b square minus 4ac divided by 2a. Now substituting the values for b, a, and c, you can see that we can have 2x cosine theta plus minus the under root of 4x square cosine square theta minus 4ac. So we can just grab the entire term, and since a is just 1, it doesn't matter, divided by 2. Now that we have z in terms of this, you can also see that w would have the same thing. Now first let's agree that z will be greater than 0. Now for our condition on SSA, I'm going to be requiring that y is greater than x. Why? You'll see shortly. It's a little bit of abuse of the fact that z must be greater than 0. But let's just put this entire equation here in this inequality. Now looking at the limiting case, let's assume that y is just equal to x. So this entire term becomes 0. So we can just rewrite the entire term back again, and you can see that the entire stuff in the under root is precisely equal to that exact thing. So it's just 2x cosine theta plus minus itself. In the minus case it would become 0, hence we must have that z is equal to plus cosine of something else. So we can do this entire process for w, and we can have z equals w. Also note that there's a minus sign there in my proof. Now we can apply SSS using this new fact, and mission accomplished.